Welcome to Lesson 2, Investigating Perpendicular Sides. If we look at a rectangle like this picture frame, we see that there are two edges that go across, the top edge and the bottom edge. We call these two edges horizontal. And the two edges that run up and down, the two side edges, here, we say that these two edges are vertical. So we have our two edges that are horizontal here and here, and the two edges that are vertical here and here. One way I like to remember horizontal and vertical is I remember that the horizon runs straight across. God first created the earth, which has a horizon, and then people came along next and created buildings that are vertical. So here where the two edges meet, we have a right corner. Do you see how here we've created a square? That's called a right corner. So where two edges meet, we say that these two edges are perpendicular to each other. Here's another set of perpendicular lines. Lines that cross each other, creating that 90-degree angle, are perpendicular. And perpendicular lines, of course, are opposite of parallel lines. Parallel lines, as we remember from Lesson 1, are lines that run together, always the same distance apart, never getting closer, never getting further apart, like railroad tracks. What do both of these shapes have in common? Well, if we look closely, we'll notice that this shape here, as we know, is a hexagon, has 6 equal sides. When we count the sides on this shape, we notice that there are also 6 sides. And because both of these shapes have 6 sides, they are called hexagons. The only difference is that the one on the right is called a regular hexagon, while the one on the left is called an irregular hexagon. For our example, we're just going to stick with our irregular hexagon. So if somebody asks you what type of shape this is, you will say, this is a hexagon. If they ask you the name of the hexagon, you can say, well, let's name the vertices. A, B, C, D, E, F. And so we are looking at hexagon A, B, C, D, E, F. There are several statements we can make about hexagon A, B, C, D, E, F. For example, we can say that line segment AF is parallel to line segment BC. This is the symbol for parallel. Here's line segment AF, and here's line segment BC. It is clear that they are parallel. You might say, hang on a second, AF is longer than BC, and you are correct. But that makes no difference when you are talking about parallel and perpendicular lines. We're not talking about the length of them, we're just talking about how they are in relation to one another. Another statement we can make is that line segment FE is perpendicular to line segment DE. FE is here, it's a horizontal line. DE is here, it's a vertical line. When they intersect, meaning when they meet, they make a right angle. And because they make a right angle, they are perpendicular, and this is the symbol we use for perpendicular. You can now pause the video, copy this hexagon into your notebook, and write down some other statements about lines that are perpendicular or parallel. So to review, here we have a horizontal line. Any line that goes directly across is horizontal. And here we have a vertical line. One that goes straight up and down is vertical. A vertical and horizontal line form a 90-degree angle when they intersect. When they intersect, we say that these lines are perpendicular to one another. This would be the opposite of two lines that are parallel, such as railroad tracks that we learned about in Lesson 1. We can name a shape by its vertices. So here we have hexagon A, B, C, D, E, F. And we can make statements about the line segments. For example, we can say that line segment BC is perpendicular to line segment CD. We can make statements about line segments that are parallel as well. So feel free to watch the video again. Hopefully you have learned more about horizontal, vertical lines and perpendicular lines. And please ask your teacher if you have any questions. Have fun with math.